What's up, y'all? This is Anthony D. Mays here to do a coding question. Today I'm going to be using Cracking the Coding Interview. That's the book that I used to prepare when I was getting ready for the Google interview. And yeah, there's tons of good questions in there. So I'm just going to take one from the moderate section and just try to work through that. I did go through and sort of pick the one that I wanted to work on. So I would love to do one where I have someone just hit me up with the question live, something that I haven't seen before, but I ain't got that kind of time right now. So this is just what you get. That said, I'm going to walk through it from beginning to end, try to get this code out as quickly as possible because, bruh, man, got to get to work soon. And I can't be spending my whole day with y'all. So anyway, let's go ahead and jump into this. So I've got an interview question here, and it reads as follows. Given an array of integers, write a method to find indices m and n such that if you sorted elements m through n, the entire array would be sorted. Minimize n minus m, that is, find the smallest such sequence. For those of you that maybe want to try this out, maybe you pause the video right here and just go back and see if you can pick out the details from the problem and get a sense for it. I'll give you an example, or an example is provided in Cracking the Coding Interview. Where's my mouse? Here we are. All right, so if I'm given this set of numbers, the output that I should produce are the indices such that if I were just to sort this section of the array, then the entire array would now be sorted. And so in this case, the output should be 3 and 9. Right, so if you look at this, we've got 1, 2, 4, 7, 10, so far so good, 11. Oh, now we dip down to 7, so we know that this is out of order. Okay, right now we're back to being sorted. Okay, now 6 is out of order. All right, so you kind of see what I mean. Like, if I'm just looking at this, I would say that the section that, okay, well, we're going to start at index 3. So technically, if I start here and go up to, where's the 9th index? Probably here. All right, so 3, 4, 5, 6, 7, 8. Yeah, so if I sort just this section of the array, that should put everything in order. And yeah, that looks to be the case. Okay, so this is what I'm looking to do. This is what I'm required to do. All right, so let's talk about my 6 steps. If you haven't heard of my 6 steps before, go to the link below in the description where I have an article that talks about what the 6 steps are. I'm just going to jump into using them right away. So normally the first thing that I would do is just repeat the question out loud. And the goal of me repeating the question out loud is just to make sure that I have a decent enough understanding of the question that I can convey to my interviewer, like, you know, I know what's going on. I don't have an interviewer. I'm just doing this by myself. So y'all can check me and let me know if I've done this incorrectly. But essentially what I need to do is, given an array, figure out where the unsorted portion is. And, what I need to do is to take an array and provide 2 indices, a start and an end index that if I sorted it, the whole array would be sorted. So that's how I would restate the problem. And so let me just take a quick note of that in my coding doc here. If we're just doing this handwritten out, I'd probably be able to go a little bit faster. And I probably wouldn't type, if I were doing a phone interview, say, I probably wouldn't type out that much information. Or maybe I would. The point is that I'm probably not going to be prompted with text in a document to help me think of the question, or at least I don't do that for my candidates. Sometimes I do, but I want to know that you're listening and tuning in, and that you know how to use the tools that you have. So for me, I'd much rather just like go ahead and write it out if it's not there. That way I don't have to think about the problem description, and then I risk forgetting details. By the way, I'm working in a Google Doc. One of the things that's important is to configure your doc correctly. So the reason why I'm using a Google Doc is because, particularly in the Google interview, this is exactly the tool that you would use in a phone interview. Other companies may have different things, but I sort of grew up using the coding doc. I'm just going to show you my preferences real quick because I think this is important. There's two settings in docs that you want to turn off. Number one is automatic capitalization of words, and the other is smart quotes. So both of these things can be issues when you're trying to type out code. If you notice like things getting capitalized when you don't want, or your quotes are turning weird, this is exactly why. So I'm just turning those off, or I have them off now. All right, let's jump back into the code. So now that I know what I'm doing, I have the example. I guess I blew that away, so I shouldn't have done that. Let me just do this one more time. I'm going to try to think of some questions that I would ask. And the questions that I'm thinking of are, well, the first one usually that comes to mind is, can I assume that everything fits in memory? And I know that can be a scary question for people to ask, but I think that it can be one of the easiest. Usually what's going to happen is as soon as you ask that question, the interviewer is going to say, yeah, assume that it all fits in memory. We'll talk about what happens when it doesn't fit in memory later on. But that's just one of the questions that always comes off the top of my head to ask. A couple of other questions that I can ask would be, will the array always have elements? Will those elements be valid? Those are a couple of questions that I could ask. In this case, I don't know that so an empty array might be an issue because what do I return in that case? I don't know. Maybe I would return, I'm thinking that I'm going to return an array that just has two elements, a start and an end index. So if I don't have any elements in the array, maybe I return an empty array, maybe I return null. I think I have the same problem to deal with if the array is already sorted. So if the array is already sorted, then there are no indices that I would need to sort. So again, maybe I return null in that case. I would probably prefer to return an empty array. And that way I don't deal with MPE issues later on. You can still get into MPE issues, sure, but yeah, I think whatever I would choose to do, I would talk to my interviewer about going one way or another. The point is that I need to figure out what the edge cases are and think about whether I'm going to handle those. Okay, it looks like I've got just integers here, so I'm going to assume that I only need to worry about integers at this point. It doesn't have to be integers, actually. Because this is a sorting problem, there could be decimal values here, there could be floats, whatever. So even though I might assume that these are integers, it may not necessarily be the case that they are in the real, or that my interviewer is thinking that. I think for this problem, that's probably not the point of the question. I think the point of the question is just to come up with a solution that will work in an optimal amount of time. So again, those are the questions that I'm thinking about. Those are the assumptions that I'm checking. This is step 2 of the process. Once I've repeated the question, now I'm asking my own and getting some clarification. Third thing is working through an example. And one of the things I always say is when your interviewer gives you an example, you use that example because they've probably designed that example for a reason. So this example is important. I think that it's worth me coming up with another example, however, that teases more of either more of the edge cases or really defines what the worst case would be. So again, I know that at some point I'm going to get to the brainstorming step and I'm going to start thinking about big O. And one of the things that's important to do when you're doing big O worst case analysis is to identify the worst case. And so I want to have an example that shows me what the worst case example is, or shows me what the worst case is, so that I can start thinking about the best that I can do performance-wise in that case. So I think in this situation, usually when we're talking about sorting things, the worst case is is typified by something that is already sorted, right? That's usually the worst case. Matter of fact, worst case in this example, I think would be something that is sorted but in reverse order. So I'm just gonna 7, 6, 5. I'll just stop there. So in this case, I want to this should return 0, and I've got, all right, 0, 5. So that's what the output should be. So in this, I would have to move pretty much every number around. Or sorry, no, I don't have to move anything because this isn't a sorting problem per se. I'm just identifying the indices. So that's an important thing. If I can avoid sorting, that would be good. But yeah, that's basically what my worst case is. And if I have a lot of these, then that could be a problem. Okay, so here's a couple of examples that I have to work off of. I'm going to leave these here and I'm going to start thinking about how I might solve this problem. Going back to the first example. So at this point, I know what problem I need to solve. Now I'm just thinking about how I'm going to solve it. And so I'm in the brainstorm step at this point. And as I think about this, I want to come up with a naive solution probably, and then a brute force solution. So let's talk about the first solution that comes to mind for me. So I think that the first way that I could solve this problem is simply by sorting the array and comparing the positions between the two. So I'm going to say sort and compare. And the idea is that, if I just go and copy this down here a little bit. Okay. The idea is that I can take this array and then let me just sort it. 2, 4, I think there's a 6, there's 3 7s. Uh-oh. 7, 10, 11, 12, 16, 18, and 19. Okay, cool. And let me just get these all lined up. I really should change my font. Matter of fact, let me just do that right now. Font, let's see, Courier. There we go. Thanks, Docs. Okay, I'm gonna go with Courier New because it's a whole lot easier for me to line things up as I need to. All right, let me get my cursor in the right place. So here I'm just gonna line them up so that everything is roughly in the same position. I think this will work. Okay, so so I've got the original array up top, I've got the sorted version down at the bottom, and if I just compare these, I can absolutely see that my first mismatch occurs at position 3. And so, yeah, that will work. And then, so now that I know where it starts, I need to figure out where the mismatch ends. And I could simply just start from the back of the array. Yeah. Using start and end pointers. Okay, so yeah, I could just do that. And I think that would get me a solution. It would be pretty simple. I just do, I don't know, quick sort on it and then compare from either end. I think that would give me, so it's going to take me big O of n log n for the sort, log base 2 of n, by the way. It's very important to say that. So this is big O of n times log base 2 of n. And then to come from either side, I wouldn't have to do that more than, I wouldn't have to make more than n moves to make that happen. So n log n base 2 plus an additional n, or plus an additional big O of n, so we don't worry about that big O of n part because it's already factored in here. This is basically a big O of n log n solution. All right, so that's the first way of doing it. One of the things that, so just naively, this is what I would do to solve the problem, and it would work and it would get things done. Is it the most efficient? No. I think that we can do better. And So the question is, how much better can I do? When I talk to candidates about brainstorming, the most important thing that you have to ask yourself is, what's the best that we can do? So as I'm looking at this, I have to look at every element. Like, that much is clear. I have to look at every element at least once. The question is, do I need to look at every element more than once? And if so, what does that do to my overall time complexity? I'm thinking that I can probably look at all the element input at least once, and I should be fine. Maybe I'd have to look at some of it one more time, and I'll explain why in just a second. So let's take a look at the top example. Okay, so I know that I have an unsorted part of my array as soon as I find an index that isn't increasing. So I assume that this is ordered because every value at position I is greater than the value at position I minus 1. So looking through this, I know that my 7 is out of order because 7 is less than 11. If this were 11, I'd be fine. This would still be considered sorted, but this is less than, strictly less than. Okay, so that's a problem. So I know how to find where my unsorted part of the array is. Now the question is, can I figure out where my sorted part of the array is? And for that, if I just march through here, again, I see another unsorted segment. I think that I would be looking for a section of the array. Well, actually, I could just come from the reverse order and just, as soon as I stop descending from the end of the array, then that could tell me. The other way that I could do it is to, yeah, I think that's the way that I would do it, is just look from the other end and see when it stops descending. All right, so in that case, if I were to do that, I would see, oh, actually, you know what? No, I have a better idea. So one of the ways that I can do this is I always know what the maximum thing I've seen so far is. And so anything that's less than the maximum thing that I've seen so far is out of order. So for instance, I have 12 here, and 6 is less than 12, so is 7. Okay, so I know that those things are going to go before 12, which means that 12 is going to need to come here. So if I know what the maximum value is of the unsorted range, that also tells me where it should eventually end up, which would give me the end of the range. So hopefully that it makes sense in my head, but hopefully it makes sense to you too. So what I could do is just go through and keep track of the largest value that I've seen so far. And by doing that, that will tell me where the unsorted elements are. All right, so let me just use another example here. I have no idea how fast I'm going. Yeah, so going back to this example, at this point, I know if I were just to mark them with an X or something. So I know that 7 is out of place because the largest value that I've seen so far is 11, and 7 is definitely less than that. 12 may or may not be out of place. It just depends. I definitely know that 6 is, and I definitely know that 7 is. All right, because up to that point, my largest value has been 12. After that, I get 16, 18, and 19. Those values continue to increase in order, so I think those should be fine. Okay, so I know where this ends. That's good. But now I've got a problem. I know where the unsorted stuff ends. So this is index 9 right here, right? But the 7 isn't in place. So I'm going to have to figure out where the 7 goes. And to do that, I think that once I've gone through and figured out where the unsorted portion is, I'm going to need to figure out, take the minimum value in the unsorted portion and move that into place and figure out where that goes. I think that I can do that in linear time. We'll see. No, actually, sorry. I don't need to do, yeah, I can find where it belongs in linear time. Because as soon as I find a value that is greater than or equal to, as soon as I find a value that is greater than, I should say, what I'm looking for, then that should do it. Let me see. Do I want greater than or equal to? Yeah, I think I want greater than or equal to. Yes. Greater than, no. Yes, greater than or equal to. Greater than. It should be greater than. And the reason why it should be greater than is because if I have, let's say that I had a 6 here, I would want to sort from here, not from here. Remember that one of the constraints is to make sure that the distance between m and n is as small as possible. So I wouldn't want to sort the 6 that's already in place. I'd want to sort after that. All right.
I've got some reminders for LA Dimes.
Oh, Google, thank you so much for nothing. Okay, cool. So I think...
No problem.
Oh. All right, so with this new situation, I think I can take in, I'm going to call this the iterative approach. And with the iterative approach, I think I can do that in big of in time. So basically, I'm going to scan through the whole array, keeping track of what I've seen so far. And then if I need to, I'll come back to the other part. Yeah, I'll figure out what that min value is and scan and put that in place. Hopefully I'm not rambling. Hopefully this is all clear. All right, so I'm going to, okay, I've identified 2 solutions. I think that the iterative approach is going to give me the optimal solution because again, I don't think I can do any better than having to look at every element at least once. So this is, because I've got 2 solutions that I can use, this is a great time for me to ask my interviewer, hey, would you prefer that I go with the sort and compare approach, or would you prefer that I start off with the iterative approach? 3 ways the interviewer can answer. Number 1, or 2 ways. They could say, look, I think it would be great if you started with the naive solution first, which would be fine. And again, because they're giving me the feedback and as it were, guiding me along in this, it's fine, right? It's totally okay for me to say, which solution would you have me take first? The interviewer has seen this problem solved probably hundreds of times, right? Or at least dozens of times. So they know what the optimal solution looks like and they know how long it takes for people to get through certain sections when they're decent candidates. And so, you know, if my interviewer were to suggest that I do the sort and compare option, that means that they probably have some confidence that I should be able to knock that out in a reasonable amount of time without it counting against me. They may also say, you know, do the iterative approach, skip the naive solution. The iterative approach should be easy enough to implement, in which, yeah, I can jump right into that. Or they may say, what do you think? In which case now the burden gets put on me, but you know, that's no different than a situation than I was in before. That's fine. What I want to do is see if my interviewer has an opinion so that I can use the benefit of their guidance to get me through, all right? So in this case, I'm just gonna go with the iterative approach and see what happens. I'm gonna write at the top of this doc. I have no idea how this video is gonna come out because my computer is like super laggy right now. I should probably get a newer one. By the way, y'all can really help me out by liking this video and subscribing. Like for real though, like that's very useful to me to help ensure that I can make more of these videos and put out content that's going to actually be helpful to you. So please don't forget to subscribe. Please don't forget to like. And if you find a mistake or a flaw in my reasoning, whatever, or you just want to say what's up, leave a comment and let me know. Okay, so I'm going to do this in JavaScript because that is the language that I'm most familiar with. I wish that I still remembered enough Java to get this done. All right, fine. Sortable indices. Feels like a horrible name, but whatever. I think that provides enough detail. All right, so I expect to get an array, and I think that's all I need. Yeah, let's just go with that. All right, so now I'm going to need an I, that's important. And we're going to start at 0. All right, what else am I going to need? I know that I'm going to want to keep track of the max that I've seen so far, so let's declare that as well. For max, let's do negative infinity. This is JavaScript. I'll tell you what I'm going to do. I'm just going to initialize it to whatever the first thing in the array is. So yeah. So the max thing that I've seen so far is just whatever the first thing is in the array. This is JavaScript, so I don't get penalized for doing this. Worst case, max will just be undefined, which is all right. Okay, the next thing that I want to do, so I said that I want to keep track of the max, but I also want to keep track of where the minimum unsorted value is, because I know that I'm going to have to go back through and figure out where that is. So, okay, let's do that then. Let min unsorted, and we're going to make that infinity, which in JavaScript we'll just represent as the max value for number. Okay, so I've got that part of it. I think I have enough variable. I'll probably need some more, but it's cool. Let's get edge cases out of the way. If the array isn't defined, then I need to return. Or if the array is empty, I should return. Or if the array only has one element, I can just return. I don't need to do anything. So I need at least 2 elements in the array in order for me to have some actual work to do. So let's just get that quickly taken care of. If it's not array or not, array.length or array.length equals, I'm going to use strict equals here because this is JavaScript. And it's just good practice to use triple equals. Yeah, okay, cool. So in this case, I'm just going to return negative, I'm going to return an empty array. All right, I think that's what I'm going to do. Okay, so now that I've got that out of the way, at this point I should have an array that has at least 2 values in it, so we're good. Actually, I think I'm going to start I at 1. Yeah. Cool. All right, so while I is less than array.length, I'm going to use a while loop here. I guess I could use a for, but I'm going to just work with this. All right, so while I is less than array.length, what I want to do is, again, going back down to my example, as I go through, I'm going to look to see if the thing that I'm looking at is less than the max value that I've seen. If it is, then I know where my issue is. So I know that that value is unsorted. Okay, so let's do that. If array I, is less than max value. All right, what am I going to do with this now? I just need to mark the start of it. So yeah, let's do that. I'm going to say let start equal, well, I'm just going to do start and end. They can be undefined. Woo, this computer. All right, start and end. All right, so I've declared those, and now what I want to do, not start, that is start isn't undefined. Then now I need to be careful because I've done not start, and if start could ever be 0, then this is going to be a problem. In this case, start is not going to be 0 because I'm starting at index 1, so this is okay. All right, so at this point, I'll make start equal to I. All right, so I just want to keep the track of that I there. So start represents the start place where I know there's something unsorted. Okay. The other thing that I wanted to do is to keep track of what min unsorted is. So I'm going to go ahead and set that. If, how do I want to do this? If array I is less than min unsorted, then I'm going to update min unsorted. I'm just, oh, now I really wish I had an IDE. The more nesting I have to do, just the crazier it gets. All right, min unsorted equals, this time I want the value, right? Because that value is what I'm going to use to figure out where it should belong at the beginning of the array. All right, so I've got min unsorted. Is there anything else I wanted to keep track of? I don't think so. I know, oh, well, I need to know where the end is going to be. So for that, I'm going to say, okay, let me break this down a little bit more. Because basically, if my thing is out of order, then, all right, I'm going to know that. So I'm going to say if start is, or if not start. Yeah, so if start hasn't been initialized yet, I'm going to set that here. That's what I want to do. Cool. There it is. And then I will just always update end in this case. Yeah, okay. So anytime I know that the value that I'm looking at is less than the maximum value that I've seen, then I'm going to update end, and that takes care of that. Cool. Will this work in the case where I've got, yes, I think this should work. All right, cool. So I think at this point, I should, by the time I get through this loop, be able to figure out where my start and end unsorted areas are, sort of, and I'll explain why in a moment. At this point, I'm just going to update I at this point. Okay, to make sure that we continue iterating through. All right, so by this time, again, I should definitely have where the unsorted region ends. I may not, however, have where it begins, and that's a problem. That's because I need to figure out where the minimum unsorted value goes, right? So let's start with a simple case. If start hasn't been initialized, right, then I know that the whole array is sorted, and I can just return what that is. Or I can return an empty array, okay? So if I haven't been able to find a place in the array that's unsorted, we should be good. Now what I want to do is deal with a situation where I've identified this unsorted region. So what I want to do, basically what I want to do at this point is adjust the start location to where min unsorted belongs. And for that, I just need to find the place in the array. I need to find the value that is greater than, the first value that's greater than the min unsorted. All right. So for this, let's just use a for loop. For let I equal 0. So we're going to start from the beginning of the array. I less than start, because I don't have to go through the whole array. and plus plus I. Okay. I guess I could use a while loop. That would also work. Okay. If array of I is greater than min unsorted, just like that, then I am going to update my start to I, and then I'm going to break. All right. So by this time, now start should be set correctly and end should be set correctly. So I'm just going to return both of these. And yeah, I think I have it. All right. So I did the brainstorming step. I've implemented this using real code. Notice that I've stayed away from using I've stayed away from using any pseudocode at all, because again, in a real interview situation, I want to just crank this code out as quickly as I can. So I've written all the code, I've articulated my thinking, I've been very clear about what I've wanted to do from beginning to end. I think that we're in okay position. At this point, I want to test my code. So I'm not ready to say, hey, I'm done, let's move on. I need to test this code. So let's go ahead and do that. I'm going to drag my example up here. My example, I equals 1. Max in this case will also equal 1. Min unsorted will equal max value. And then start will equal undefined. As was end will equal undefined. Maybe I could put that on a separate line. Yeah, I'll just do that. Okay, so we do that. Our array is normal, so we can skip the edge case check. I know that that's all good. Okay, so while array I is less than array.length is, how many numbers are here? 5, 10, 13. All right, array.length equals 13. Okay, so, all right, triple equals for those of you who are, critics. Okay, so if array I is less than max, array I in this case equals 2. So we're okay there. If it's less than max, it is not less than max because max equals 1. Okay, so I don't need to worry about that part. If array I is less than min unsorted, it is. So min unsorted will get equal to whatever the value is. Okay, so min unsorted in this case will be 2. I'm making a horrible mess of this. Forgive me. All right, so that's that. And then I'm going to increment I. So now I equals 2. Max at this point equals 1 still. Because I haven't updated max. I wonder if I'm going to have to worry about that. Min unsorted is 2. Array I now equals 4. All right. This process is going a lot slower because I'm actually putting the variables in place. If I were at a whiteboard or something like this, this would go a little bit faster. Okay, but let's just continue going. If array I is less than max, array I at this point is 4, and max is 1, so no, we're still good. Okay, min unsorted at this point will be, min unsorted is 2 here, so I don't need to worry about that. All right, it's 4. Actually, I should qualify this. I don't want to update min unsorted for no reason. Okay, so I want to make sure that I've actually entered into the unsorted region. So I'm just going to make sure that start is set first. Okay, so there we go. I'm going to change this to max value. So just make it back to what it was. Okay, cool. So I think I found a bug. I just got that worked out. So let's just get straight up to the unsorted portion. So at this point, that would be I equals 7, right? At this point, max should be 11. Wait, do I actually update max? No, I don't. Okay. Let me do that. That's a problem. Testing. Seriously, always do it. Check yourself before you wreck yourself. That's how we say it where I come from. Okay, max equals, I'm just gonna, yeah, array I. There we go. Bug found. Cool. So max at this point is 11. Again, I'm moving to this part where I know that the value is out of order. So max should be 11 at this point because where I was 6, that was that. And then array I equals 7. Cool. So while I is less than array.length is 13, we're fine. So now array I is less than max. That's fine. If not start, so start is still undefined because it hasn't been set yet. So we're going to set start to I, in which case this is 7. No, 6. 0 based. Okay, so start is 6 and end will also be 6 because that's what we're doing. Okay, cool. All right, no need to update max because I know that array I is less than max, so we're fine there. Okay, if start is defined, so at this point start is defined, and array I is less than min unsorted. So min unsorted right now is max value, so yes, this is true. I get to now update max value with 7 because 7 is array I. Okay, cool. I think we're good there. All right, so I'm pretty sure that I can continue through this loop. You can continue check as an exercise for the reader, but I think the point here is that you can see that by walking through this code step by step, evaluating, keeping track of the variable state, all that stuff, I'm able to find bugs in the code that impact the quality. There may be some additional bugs here, but right now I'm just going to settle on this and put a stop to it because bruh man's got to go to work. So anyway, I think this is okay. I don't know if this is necessarily the shortest solution. I feel like maybe we can make this a little bit shorter, but if I look at cracking the coding interview, or if I look at the solution for this problem, hopefully it will look something like this. What you can do is if you have the book, go check it out and see how it's different. I'm not gonna check it, and let me know if I've got something horribly wrong in the comments and we can talk about it. But the idea here is that I think I've got a solution that's optimal. I think that this is something that is going to work. And I believe that I've reached something that is optimal because of the thinking that I've done in the brainstorming step. So this is how I go through interview questions. Hopefully this is useful to you. Again, if you want to see more videos like this, it's super useful to me if you give me some feedback, like, comment, most importantly, subscribe. That's just going to make sure that I know that I'm producing the right content for you and addressing the things that you want to have addressed. So anyway, thanks a lot. This is Anthony D. Mays. Peace.